Example 3.2.1, draw a box plot for the data on blood glucose levels of females from example 3.1.1. So going back to example 3.1.1, that was this data here. So since we're going to draw a box plot, we need to know the lowest value, the quartile, the median, biggest value. So going back to that data, we had 1.7 was an outlier, and then the next highest value after that was 2.2. Let's start with those in our box plot. 1.7 was an outlier, and then the lowest value after that was 2.2. So 1.7 was the lowest value. There's 5 little squares here, so each square is worth 0.2. So 1.7 is going to be there, halfway between 1.6 and 1.8. That's our outlier of 1.7. And then the next value after that, which wasn't an outlier, was 2.2. So that goes there. I'm not going to draw the boundary for outliers. We tend to draw that when it's grouped data and we don't have the raw data. But here we have the raw data, so I don't need to. Let's go back to the data. What was the lower quartile? It was 3.2. Upper quartile was 4. And then the biggest value was 5.1. We didn't find the median earlier. We're going to need that as well. So 3.2, 4, and then 5.1. So 3.2 is here, and 4 is there, and then 5.1 is there. Also going to need the median as well. I'm just going to draw my box and we'll go back and get the median later. So the lower quartile was 3.2, the upper quartile was 4. So I'm going to draw a box. It doesn't matter how tall the box is, that doesn't matter at all. Going from 3.2 up to 4. And then we should have a line as well running through there. Just going to make that line a little bit thicker. And the box as well, so you can see it. Now actually we don't tend to draw the line going right through the box. So I'm just going to change that and instead draw it from the lowest value up to the lower quartile and then from the upper quartile to the highest value. Sorry about that. Right, now I need to go back and find the median. So I've gone back to example 3.1.1. The median we're going to work out right now, so we can go on our box plot. There were 30 females, so if you work out n over 2, which is 15, and just like we did when we found the lower quartile and the upper quartile, if you get a whole number, then add a half, and that gives you the position of the thing you're looking for. So the median is in the 15.5th position, or the 15.5th value is the median. Now we're looking the way the numbers have been given to us in this example. They're perfectly lined up. So we can see there must be 15 on the top line and there must be 15 on the bottom line as well, because they are perfectly lined up. So the 15th value will be 3.8 and the 16th value will be 3.8. We want to go halfway between those. Halfway between 3.8 and 3.8 is also 3.8. So that is the median, 3.8. That can now go on our box plot. So here's the box plot. The median, I'm going to draw a vertical line at the median, which was 3.8. Once again, I'm just going to make that a little bit thicker. There we go. That is our box plot for the female data. Just going to make sure that outlier is visible. And also the lowest and highest values. There we go, that's our box plot. There is one thing I've forgotten to do, and that's label our scale. We must always label the scale and label the graph as well. So the scale is blood glucose level. Make sure you label it. And also what the units are. Again, you don't need to understand what the units are in this case. Just make sure you include them. That's the scale. And then also make sure you label your graph as well. So this is the data for the females. Right, now back to the question. That's part A done. Part B, we're given some data for males, and the results are summarized below. We've got quartiles, the median, lowest value, highest value. An outlier is going to be an observation that is either 1.5 interquartile ranges above the upper quartile or 1.5 interquartile ranges below the lower quartile. Part B, given that there is only one outlier for the males, draw a box plot for this data on the same diagram as the one for the females. That's why it's really important that we label them females and males. Right, so back to the graph paper. I should have thought ahead and looked at part B and thought we're going to draw two graphs on here and made this one a little bit less tall, but never mind. I'm going to put it onto here anyway. Right, so I've copied the data from earlier in the question, so I'm not scrolling up and down all the time. We were told there was only one outlier, so let's find out where it is. We were told to use the rule of interquartile range plus or minus, sorry, the upper quartile plus the 1.5 times interquartile range, or the lower quartile take away 1.5 times interquartile range. So we need to know what the interquartile range is. So upper quartile take away lower quartile, that's 1.1. From that we can get our outlier limits. So it's either the upper quartile plus 1.5 interquartile ranges, or it's the lower quartile take away 1.5 interquartile ranges. So the upper quartile was 4.7, add 1.5 times the interquartile range gives us 6.35. That's the upper limit for outliers. And if I just tweak that and change the upper quartile to the lower quartile, 3.6, and then take away 1.5 interquartile ranges, get 1.95. So those are the limits, the upper limit, the lower limit. Let's look at the upper limit, 6.35. The highest value is 5.2, so that's not an outlier. But if we look at the lowest value of 1.4, that is lower than our lower limit. So 1.4 is the outlier. So 1.4 is an outlier. And we're told there was only one outlier. So that's that. Right, let's put these on the graph. So 1.4, which is there, is an outlier. Now we don't have the raw data for the males. If we go back, we've just been given the results, the summary data. We don't have the raw data. So where do we put the beginning of our box plot? Well, it's in this situation where we'd now draw it at the limit, the lower limit for the outliers. So 1.95. So 1.95 is where we're going to draw the beginning of the box plot. So 1.8, 1.9, 1.95 will be about there. So 1.95, this situation where we would use that rather than an actual value, because we don't have those values, we don't have that data. So then the lower quartile 3.6, which will be there. Median 4.0, upper quartile 4.7, and the highest value of 5.2. There they are. Let's draw the box from the lower quartile to the upper quartile, and then these lines now. Just gonna make those a little bit thicker. There we are, a bit thicker now. It should be easier to see. The scale on the axis is already there. So let's make sure we label this as the data for the males, so we know which is which. It's a bit squashed up at the top, but the height of the box plot doesn't represent anything, so that's okay. I can get away with that. It would just been a bit neater if I thought ahead. So part B done. Draw the box plot for the males on the same diagram as the females, because that allows us in part C to compare the data for both. It's important when you're comparing data like this that you use the same scale, and we have. So now we can do some comparisons. As said in the notes earlier, when you are comparing data, compare a measure of location and compare a measure of spread. So here the only measure of location we have is the median, and we can see that the median for the males is greater than the median for the females. So you can start by saying the median blood glucose must be in context. Don't just say the median is bigger for the males. Median of what? Always include context. The median blood glucose for males is higher than or greater than the median blood glucose for females. We can see that from the box plot. We also see it just by comparing the numbers as well. So that's a measure of location compared. Now we're going to compare a measure of spread, a measure of dispersion. And there's two that we can easily see from a box plot. There's the range and there's the interquartile range. So the interquartile range goes from the lower quartile to the upper quartile. And we can see it's bigger for the males than it is for the females. You can work out what the numbers are if you want to. But on a very basic level, look at this little squares. So this goes 1, 2, 3, 4, 5.5 squares. Whereas for the females, it's 1, 2, 3, just 4 squares. So the males do have a greater interquartile range, and the range as well. From the lowest value, don't ignore the outlier. From the lowest value, which is the outlier, all the way up to highest value, that's the range. And again, it's greater for the males than it is for the females. So there's more than one way of wording this answer. But I've said the range and also the interquartile range. In blood glucose, we need the context here. Remember the context. For females is smaller than it is for the males. Of course, you could have said the range is greater for the females. That's the equivalent of what I just said. Okay, that concludes this example.